Okay, so for today's lesson, we're not technically doing any new shapes. We're just combining shapes that we've already been doing and seeing what it looks like when you put them together in what's called a composite figure. It's a combination of two or more shapes. So our opener says to us, often in the real world, two or more solids are combined to make a composite figure. This changes the surface of our shape, and often a part of the surface area formulas must be added or subtracted. So if we look at this first one, our first question is, what are the solids in our composite figure made of? And so we know that we have the cone and we have the cylinder. So cone and cylinder. Okay, and then what are the surface area formulas for each of these solids? So cone is pi r L plus pi r squared, and the cylinder is 2 pi r h plus 2 pi r squared. And so cone. Okay, so our next question is, write a formula for your composite solid by combining the appropriate pieces of the individual formulas. So what do they mean by that? So let's go back up and look at what we have here. So this is going to require you to truly understand what the formulas mean. To this point, you may have just been memorizing formulas, or maybe not even that, just writing them down from your notes. But it is important that you understand that this first part, the part that comes before the plus, is the lateral area. It does not include the bases. Everything that comes after the plus is part of the bases. So bases, 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 and then we have our lateral area is the sides, right? So there we go. All right, so in the cone, let's start with that. We have the lateral area, the area of the sides of this cone, and then we have the base. Now, when we're talking about the composite solid figure, we're finding the surface area. Remember with me that surface area is basically all the parts of this figure that are touching the outer air. So when I put this cone on top of this cylinder, the base of this cone is no longer touching air outside the figure. It is now inside the figure. So it is not included in the surface area. We don't need the circle base. It's like if we were to take this thing and glue those together and then dip it in paint, what would have paint on it? Well, the base of that cone would not have any paint on it because it would be inside the shape. All right, now let's look at the cylinder and see what parts of that are still exposed to air. So for the lateral area, right, for the sides, the paper towel roll, if you want to think of it like that, right, that part is still going to be dipped in paint. It's still exposed to air. But if you're thinking about the bases, the two circles, right, is what this is, two circles. The bottom would absolutely be exposed to air. It would be dipped in paint and have paint on it if we pulled it out of paint. But the top of the cylinder would not. And so we are only going to have one circle, not two. So we're only going to have 1 pi r squared to account for the circle on the bottom, but the circle on the top is on the inside of the shape, so we don't need it. So back to question C down here. Write a formula for your composite solid by combining the appropriate pieces. That just means the pieces that we need, the pieces that are on the outer surface of this shape. So essentially we have pi RL from the cone, pi RL, plus we're going to add the pieces of the cylinder we need, which was just the 2 pi RH for the lateral area plus 1 pi r squared. So if you added all that up, that would be your composite formula. All right, and then in the last part, we get to actually find the surface area. So I'm going to go back up here to do that. So I'm going to erase my pi r squared since I don't need that. And we're just going to make that 1 pi r squared for that base. So in my picture, it appears that 12 is my diameter. And so if 12 is all the way across the circle, then we know my radius would be halfway across the circle. It would be 6. What else do we have? It looks like the height, the distance between my circle bases on my cylinder is 8. Okay, so it looks like we have the cylinder part here. We have the 2 pi RH. We have 2 pi times 6 times my height of 8 plus the 2 pi r squared. 2 pi times 6 squared. And we're going to write this as a decimal. Don't worry about leaving it in terms of pi or anything like that. A little bit trickier though. Let's go look at this cone. On our cone, what this 8 represents is straight up. It goes from the top straight down for 8. We also know that our radius of this circle is 6. What I don't know is my slant height, my L. So I can't yet find the surface area of the cone because I need L. So this is going to be, looks like we need to do the Pythagorean theorem on this little, I'm going to make it a green right triangle here. You might recognize that this is a triple. Okay, so that's 6 squared plus 8 squared equals c squared. So 36 plus 64. So c equals 100. Square root that, it is indeed 10. Okay, so our slant height is now 10. Using this green right triangle, we figured that out. So we now have pi times radius, which is 6, times L, which is 10. All right, and now here comes the fun part. We're going to take this part and put it in our calculator, and then we'll add those suckers together. So I'm going to go ahead, this is basically 6 times 10, which is 60 pi, or if you put it in your calculator, we get 188.5. And you know what? We don't want to round our intermediate values. We want to use all the decimal places, so 188.49555. Okay. And then for this second part, I'm going to go ahead and put all this in my calculator at once. Oh, and look what I did. Out of habit, I put a 2 on that pi r squared there. Silly me. Because it's now just 1 pi r squared. And so that comes out to 414.690. Again, we're not rounding those intermediate values. And now we're going to add these two numbers together. For a final answer of 603.18, or to the nearest tenth, 603.2 meters squared.